All right, hello class. Welcome to this Chapter 5 exam review. So we're going to cover the questions from the review on Canvas. So if you have any trouble with the questions, or you just kind of want to review, then this is the video for you. Let's go ahead and get started with question 1. Right, so we're looking for PR and X. So let's go ahead and find X first, and then we'll use X to find PR. So notice that in this diagram, they told you that this is the same distance. This right here is the same distance as that. So that means these have to be equal to each other. So it's just a matter of solving that equation. So I'm going to go ahead and subtract 3x on both sides. And then I'll move this number over to the other side by adding it. So we have 3x equals 15 divided by 3 on both sides. So x is equal to 5. Okay, so we have 5 as our value, and then therefore we can find PR. So we're going to plug it in here. So that's going to be 3 times 5 plus 5. So this is going to be 15 plus 5 is 20. And because this is 20, that means this also has to be 20. Okay, so then we're looking for PR, which is this whole thing. So that means we're going to have to add the 20 plus the 20 for each of those sides, and then that gives us a total of 40. All right, question 2. Here we're looking for a comparison between BC and AC. So we're going to have to compare, if we want to compare BC here, where we're going to have to look at the opposite angle, which is 78. And if we want to compare AC, if we want to look at AC, we're going to look at the opposite angle, which is this angle here. Well, the problem is we need to find that angle. However, it's pretty easy to find that angle because we know that if you have a straight line and part of the angle is, say, 78, like it is here, then you can figure out this other angle because these two angles have to add up to 180. Okay, so we have x plus 78 equals 180, and these are supplementary angles. And so we're going to subtract 78, and we get 102 degrees. So that means this is 102 degrees, which means 102 is bigger than 78. So because 102 is bigger than 78, that means AC has to be larger than BC, so which means that BC is smaller. So we're going to say this is smaller. All right, question 3. A school principal is mapping out some new features for a triangular playground. He sketches the playground on grid paper. The coordinates of the new vertices of the playground are 110, -5, 2, and 7, 2. Principal plants a tree at the Circumcenter. What are the coordinates? So we're going to plot the coordinates here, 110, and 7, 2. All right, so we got our triangle. And so next we're going to figure out the circumcenter. Now the circumcenter, remember, is related to the perpendicular bisector. And if you recall, the mnemonic that we used for that was my cousin always owes Anna banana ice cream, probably before Christmas. So this is going to help us figure out which one goes to what. So we have, because we're dealing with the circumcenter, that's going to relate to the perpendicular bisector. So we need to look at a perpendicular bisector. So that means we need to cut a side in half at a right angle. Now we're going to do this bottom side because that's the easiest one to do. So the length of this line segment is 12. If you were to count as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So that means that we're going to cut it in half by cutting it at the 6 mark, right? 6 spaces in. So 1, 2, 3, 4, 5, 6. So we're going to cut it right here. And so it's the same on each side. Okay, so then notice that it lines up perfectly with this vertex here. And again, if you wanted to figure out the halfway point of between any two points, you simply have to average the x and the y coordinates. So in any case, we have this right angle here. And so this right here is my perpendicular bisector. We're going to need to figure out one more perpendicular bisector on another side. So we're going to choose this left side to do the perpendicular bisector for. So we're going to have to figure out the midpoint. Where is the midpoint on that line segment? Okay, so if we want to figure out the midpoint, you're going to average the x and the y coordinates. Okay, so we're going to try to find the midpoint of -5, 2, and 1, 10. So let's figure out the midpoint of that. So you're going to add the midpoint. We're going to find the x. We're going to add the x coordinates together, add the y coordinates together, and divide them by 2. So -5 plus 1 over 2, 2 plus 10 over 2, and that'll give me my midpoint. So this case, -5 plus 1 is -4, divide that by 2. 2 plus 10 is 12, divided by 2. So -4 divided by 2 is -2. 12 divided by 2 is 6. All right, so that's my midpoint. So my midpoint here is -2, 6. And we'll label that on here. And that kind of makes sense based off of, that looks like it's in the middle. So far so good. All right, so now we're going to cut this at a 90-degree angle. All right, in order to do that, we need to figure out the slope of this line. So we're going to go ahead and do the slope first. So let's do the rise over the run between those 2 points. So it rises 8 and it runs a total of 6. 1, 2, 3, 4, 5, 6. Yeah, that's correct. And then we're going to divide. So basically the slope of that line, 8, 6. So it's going to be slope equals 8 over 6. But then remember that reduces, you can divide that by 2. So then the slope is equal to 4/3. All right. Now next we're going to figure out, well, what is the perpendicular slope to that? So we're going to figure out, okay, well, what's the slope of this blue line have to be to make it a 90-degree angle? Well, in order to do that, you're going to need to flip this and change the sign. So the slope for the blue line is going to be negative, and then you're going to flip it so it becomes 3/4. All right, and that will ensure that this cuts at a 90-degree angle perpendicular to it. All right, so the slope of that blue line is -3/4, and now we're going to figure out, well, that means that we're going to go down 3/4. Okay, so down 3/4, so 1, 2, 3, and then 1, 2, 3, 4. So there's my point there. I'll go ahead and go a little bit further. 1, 2, 3, 1, 2, 3, 4. Okay, so it basically ends there. So we can draw a line, and I'll go ahead and draw it as a dashed line. Doesn't really matter, but I'll draw it as a dashed line. And it's not a perfect line because I'm not using a ruler or anything. You want to use a straight edge ideally when you're doing this. Okay, so there's my line somewhere around there. And so where they cross is where my circumcenter is. So somewhere around there is my circumcenter. And I need to figure out, where that is. So I need to figure out the equation of that blue line and then figure out, okay, well, what's the equation of the blue line? What's the equation of this dashed black line? Well, the equation of this dashed black line is really easy. It's x equals to 1. Okay, and that's because it's a vertical line. Remember that vertical lines have an equation x equals a number. And obviously the x coordinate of this is 1 because it's crossing the 1 there. So it's at the 1. All right, now let's find the equation of the blue line. The equation of the blue line, we know that the slope of the blue line is -3/4. We know a point on that blue line because the point that is on that blue line is it's going to be the -2, 6, right? That's the point on that blue line. So let's put this in blue. So we know a point and a slope. So we should be able to find the equation of this blue line. All right, so let me change this real quick. Okay, so we have here y equals mx plus b. We know our slope. Remember, slope is m, right? So we're going to plug that slope in. -3/4 x plus b. Next, we'll go ahead and plug in x and y. So x is -2, y is 6. So we got 6 equals -3/4 times -2 plus b. Again, we can convert this to a decimal, or we can use the fractions. It doesn't really matter, but I will convert this to a decimal, okay? So I'll change that to -0.75, and I'll change this to -0.75 as well. Okay, so this is going to be 2 times -0.75 is, it's going to be 1.50, and then we'll subtract 1.50 on both sides. And so b is 4.50. Which means that we can replace the b here with 4.50. And I'll do that here right now. Okay, so this right here is my equation. That's the equation of that blue line. So I'll write that equation there, -0.75x plus 4.50. All right, so that's my equation, and we want to figure out where these two lines cross, which means we're going to set basically we're going to set them equal to each other. And what I mean by that is, you're just going to plug one into another. Okay, you're going to do a substitution. Okay, so I'm going to substitute this x equals 1 into that equation, and that will give me the y value. So we know that they cross at x equals 1, right? So we know that. So because it's right at this x value. Okay, so the x value we know is 1. Now we need to figure out the y value, right? So where on the y-axis. So we're going to plug this into x equals 1 to get the y value. So let's do that. And we'll do that over here. So we get y equals -0.75 times x is equal to 1 plus 4.50. And so we get y equals -0.75 plus 4.50. 4.50 minus 0.75 is 375. Okay, so there's my y value. And therefore, my coordinates are 1, 3.75. And that kind of makes sense. If you look at that, that's about 3.75. This is a little bit less than 4, but between 3 and 4. All right, so that's the coordinates of my circumcenter. 1, 3.75. Remember the importance of the circumcenter. While I'm at it, we got the answer, but while I'm at it, the importance of the circumcenter is that tells you the point such that the distance to each of the vertices is the same. So like these green distances are equal. All right, so, and then if I were to draw a circle with that radius, and that right there is my circumscribed circle. And that's why it's called a circumcenter. And that touches the corners of the triangle, as we can see. But this is just a little extra information because we're gonna, just to kind of remind you what the circumcenter is. All right, so we're gonna do the same thing here, but this time we are looking for the orthocenter. So I'm gonna plot the coordinates real quick. So we got the same coordinates, 110. Go ahead and connect those. Right, so now we want to figure out the orthocenter. So now using the analogy, my cousin always owes Anna banana ice cream, probably before Christmas. So if you use that mnemonic, well, we're looking for orthocenter. So that has to do with altitude. Okay, so that's altitude So we need to do an altitude. Altitude, remember, is a 90-degree angle from the vertex to the opposite side. And we already know that when we use this vertex, that's going to lead to a 90-degree angle if we go straight down to the opposite side. And that's the reason for that is because this is an isosceles triangle. And that is actually the same on both sides if you were to measure the distance. Okay, so that's a special property known as the isosceles triangle theorem, that you're on a perpendicular bisector if the distances here are the same. The converse of that. So anyways, so we got, that is my altitude, and we're going to draw an altitude from this corner onwards to onto the left side. So we're going to draw it outward like that. And in order to do that, well, first off, we know that the slope of this line has to be negative. Well, we said it earlier, it was the slope of the negative 5, 2 line and the 110 line. We said that it was, if you go back, slope was 4 over 3, right? So that was the slope of that one. We said that the slope of this was 4 over 3. And so the slope of the perpendicular line has to be negative 3 over 4, right? And so we're going to do the same thing here. We're going to figure out the equation of the line that's going to go from this corner onwards with a slope of negative 3 over 4. Okay, so we're going to clearly use this point because we're going from that corner. So we're going to use negative 3 over 4 and 7, 2 as my information for the equation of the line. So let's go ahead and find it. Y equals mx plus b. Let's plug in the slope. Now let's plug in x and y. Again, we said that we were going to replace this with a decimal, right? So I'll go ahead and do that now. And then x is equal to 7. And so 7 times negative 0.75, it's going to be negative 5.25. All right, and then we're going to add that over to both sides. So b is 7.25. All right, so we got our b, and let's go ahead and replace that b with that. So let's do that now. Okay, so that's the equation of that line, and I will mark that. So let's go ahead and draw the line. We know that the slope has to be negative 4 over 3, so that means we're going to go, or negative 3 over 4 rather. So I'm going to go up 3, left 4. 1, 2, 3, 4 over here. Up 3, left 4 again. And then we'll connect those the best we can. Okay, so that right there is my altitude, and we said the equation of that is y equals negative 0.75 x plus 5.25, or 7.25. Okay, and the equation of this black one we said was x equal to 1. Now to figure out where they cross, right, we need to plug in the value of x into that equation. So I'll do that up here. So y equals negative 0.75 times 1 plus 7.25. And this is going to be negative 0.75 plus 7.25. So the y value is going to be 6.50. And so my coordinates are going to be 1 and 6.50. So the coordinates here, where they cross, is x equals 1, which that makes sense because it's right there, and 6.50. And that makes sense because it's halfway between the 6 and the 7. So we know we're doing this correctly. So we got our coordinates, 1, 6.50. All right. And that is it. So if I were to draw another altitude from here, it would also cross that point. All right, so that's number 4. Let's go ahead and do number 5. Same deal, but this time we are looking for the centroid. So I kept the coordinates the same just to keep it consistent. right, so now we're going to figure out again, we're going to centroid. So remember, median, or my cousin always owes ... This right here is the centroid. So that means that centroid has to do with median. So we're looking at medians here. Median cuts the segment an opposite of the vertex in half. So if we look at this vertex, we're going to cut this in half. It basically meets at the midpoint, and the midpoint means that both sides, the distance on both sides are equal. Okay, so basically the median is the same thing as the perpendicular bisector, which is the same thing as the altitude in this particular triangle, because this is an isosceles triangle. But that's not always going to be the case, right? Now we're going to go from this corner to the opposite side here, and draw a median as well. Okay, so remember, the median cuts the segment in half, so that means we need to figure out the midpoint. But we already know the midpoint of this segment. The midpoint of this segment we found earlier was 2, 6, and therefore we can reuse that here. All right, so now I'm going to draw my other median the best I can. So maybe something like that. Okay, and that's going to be my other median. So we got our two medians. Where they cross is going to be my solution. So let's figure out the equation of this median here. In order to do that, remember, I'm going to have to do rise over run. So let's go ahead and do the rise. How much does it rise? And how much does it run? Okay, so basically it drops down, looks like 1, 2, 3, 4. It drops down 4. So that's going to be -4. And it goes to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes to the right 9. So the slope here is the slope of this blue line, and I'll do that, is equal to -4/9. Okay, so we got the slope of that line. We're going to pick one point on that line. So let's pick the 2, 6 point, or the -2, 6 point rather. That should be a negative. And I don't know if yeah, okay. Just want to make sure that I kept the same coordinates. All right, so let's see here, -2, 6. Let's choose that point. You could choose the -2, 6 or the 7, 2. Doesn't really matter, as long as you pick one point on that blue line. All right, so now we're going to find the equation. Again, same thing like we did before, y equals mx plus b. Let's plug in the slope. Now let's plug in the x and plug in the y. Let's convert this to a decimal. So this right here as a decimal is -0.44, going forever. So just to make the calculation a little simpler, I'm going to do that. So this is going to be -0.44, that fraction here, and then x is -2. And then we get -0.44 times -2 is +0.88. So it's really about 0.89. So because it's 0.8888 going on forever, so I'm going to round it to 0.89. Okay. And that's the only reason I'm doing that. You could leave it as 0.88, but it's going to be a little bit off by a hair. In any case, we're going to subtract 0.89 on both sides. And we get 6 minus 0.89 is 5.11. And that's going to be my b. Let's go ahead and replace this with the fraction that we said we were going to replace it with, 0.44. And then we'll replace this b with 5.11. All right, so now we got our equation. I'm going to list that equation over here. And we know the equation of this black line, which is x equals to 1. And so where they cross is where you're going to plug this into there. You're going to do a substitution. All right, so x equals 1 plugged into y. So y equals -0.44 times the x value of 1, which I'll color code that, plus 5.11. So we got y equals negative 0.44 plus 5.11. $5, I think of it in terms of change. $5.11 minus 44 cents. Let's see here. So we got 4.64. All right, so that is my y value. So, and we're going to see if that makes sense. So that means my coordinates here have to be 4.64, which that makes sense. 4.64, it's a little bit over 4.5. So that makes sense right there. Okay, so we got 4.64. All right, so now the interesting thing about the centroid is that it follows the 2/3 rule. So now this has to be half as big as that. So like if this were 2, then this would be like 4, for example. Okay, so that's the interesting about the centroid, is it divides the triangle accordingly to that fashion. All right, so let's look at question 6. So we're going to make a choice of whether it's a median, altitude, etc. Okay, so segment EX. So we're interested in EX. So segment EX is going from the vertex straight down at a right angle. So that's going to be an altitude. All right, segment WF. That's this one right here. So WF this time is going from the vertex to the midpoint. How do I know that's the midpoint? Well, because these two are equal to each other. So that's the midpoint. So it's going from F to W at the midpoint. And therefore, it is a median. All right, segment DZ. DZ is going from the vertex to the opposite side. And that's all it's doing. But it's also cutting the angle in half. So if it cuts the angle in half, that means it's an angle bisector. All right, segment VY. VY is right here. It's going from the midpoint of this segment. So these are the same distance on both sides. It looks like it's the same distance, right? And then it's going at a 90-degree angle to the opposite side. And that is a perpendicular bisector because it's a 90-degree angle and it's cutting the side in half. So that's perpendicular bisector. All right, question 7. X is the centroid. What is AZ if XZ is 3? So we know XZ is 3, which means that this right here, remember the centroid follows the 2/3 rule. That's just what I call it, the 2/3, 1/3 rule. So basically it's always 2 parts to 1 part. So this is always 2 parts to 1 part. So that's the ratio of the line segments. So that means the longer part is twice as large as the smaller part. So if this smaller part is 3, then this larger part has to be 6. You just double it. And then 6 plus 3 is going to be 9. And so AZ is 9. Now let's look at CX. What is CX if CW is 15? So CW, that whole thing is 15. Which means that we need to figure out a number that is, well, we know it's split into 2/3, 1/3, right? So 1/3 of the line segment is 15, or 1/3 of 15 is WX. So this is clearly the 1/3 one, and this is clearly the 2/3 one. The bigger one is the 2/3. So let's figure out the 1/3. So what is 1/3 of 15? All you gotta do is multiply those two numbers. Put this over invisible 1, and then multiply straight across. So you got 15 times 1, and then 3 times 1. 15 divided by 3 is 5. So that means that this is 5. And so if you double that, you get 10. And so CX is 10. All right, so let's look at the next problem here. Question 8, what is the measure of angle BAC? So we have, so in this diagram, you can see that from A to D, we have cut this triangle in half. So that means, and then we know that, so that means this is a perpendicular bisector. We have cut this in half, and the reason I know that this is perpendicular is because the distance from here to here is the same, which means that by the converse of the perpendicular bisector theorem, that means we are on a perpendicular bisector. And so that also means that for this, that we're looking at an isosceles triangle, which means that these angles are the same, and these angles are clearly the same because they're 90 degrees. And that also means that these are the same because the other two are the same. Okay, so this is based off of that information, we know that these two have to be congruent. Okay, so we have 2n plus 7 has to be equal to 5n minus 2, and we can solve that. So we have 2n plus 7, so 5 minus 2, and then we're going ahead and I'm going to put the n's on, move this n over to the right-hand side. So we have here 7 is equal to 3n minus 2. We're going to go ahead and add the 2 on both sides here. We get 9 equals 3n, divide by 3. N equals 3. Okay, so we got our n, and we're going to plug that n into either one of these. It doesn't matter which one. So I'm going to plug it into this one. So if I do that, I get 2 times, we said it was 3, so 3 plus 7. 2 times 3 is 6. 6 plus 7 is 13. So this is going to be 13 degrees, and because we said that they're equal to each other, that means this is also going to be 13 degrees as well. And so we know that BAC, which is this whole thing, you have to add those two angles. So we're going to add 13 plus 13 and get a total of 26 degrees for that angle. All right, so the answer is 26 degrees. And we just type in 26 into the answer. All right, question 9, let's complete the statement. So it says here, angle bisectors meet where? So where did the angle bisectors meet? This is a perfect, just example of just knowing just knowing the facts of what we discussed as far as vocab is concerned. So if you remember, my cousin always owes Anna banana ice cream. Probably before Christmas, right? So we know that the angle bisectors, that's this right here, angle bisectors, meet at the end center, right? So this is the end center. So they always meet at the end center. We know that perpendicular bisectors meet at the circumcenter. And then we know that medians meet at the centroid. And then finally, altitudes meet at the orthocenter. All right, and that's just a vocab question, so you know what that is. Question 10, what is a possible range of values for x? So we're going to have, so if we look at this diagram, we know that this is a hinge theorem problem because we have these are the same. We have this side shares with itself, so obviously those two are identical. It's equivalent to itself. So we have two pairs of congruent sides, and therefore we can compare the angles here directly. So if I compare 2x minus 4, I'm going to go straight to the opposite side, and that's going to be this side right here. I'm going to go straight to the opposite side here, which is going to be 50. Which one's going to be larger? Well, clearly 50 is the larger number. So that means that this is the larger angle. So that means 28 is bigger than 2x minus 4. So that means that 2x minus 4 has to be less than 28, right? By that logic that we just said. Okay, so we can go ahead and solve this inequality. We'll solve it by adding 4 to both sides. Then we'll divide by 2. So x is less than 16. All right, so we got this part right here. X is less than 16, but X has to be bigger than something as well. There's a limit to how large this angle can be and how small it can be. Remember, we said that the smallest that a given angle can be, in this case, the angle that we're interested in is 2x minus 4. The smallest that it can be is just below 180. And the largest it can be is just above 0. So you can't be 0 degrees, otherwise it's not a triangle. And you can't also be 180 because then it won't be a triangle anymore either. So which one are we going to use? Well, it doesn't make sense for us to use the less than 180 because we already know that it's less than 16 and 16 is less than 180. So it doesn't really make sense for us to use that here. So therefore, what we're going to do is we're just going to ignore that and we'll use the greater than 0. That will tell us some new information that I need to know. All right, so let's go ahead and figure that out. We're going to add 4 to both sides. So this is going to be greater than 4. Divide by 2, divide by 2. X is greater than 2. All right, so X has to be greater than 2, but less than 16. All right, so question 11, write an inequality relating DAC to BAC. Okay, so DAC, we're looking at that angle there. And BAC, we're looking at that angle. Okay, so which one is bigger? Well, we know we're doing a hinge theorem because this is the same as that, and this is congruent to itself. So we're going to look at the angle opposite, the side opposite of that angle, which is this one. The side opposite of this angle, which is 13. 14 is bigger than 13, which means that DAC has to be bigger than BAC, and so therefore it's greater. Write an inequality relating DC and BC. So this is the, in this case, this is the, we're dealing with the hinge theorem and the converse of the hinge theorem. So for this one, we're going to compare the angles. So if I look at this angle and this angle, 30 is going to be bigger than 25. And therefore, if I go to the opposite side for that and for this, that means that BC has to be bigger than DC because 30 degrees is larger than 25. All right, a frame designer is making a triangular frame. She has 2 sides of length 18 and 27 inches. What are the possible lengths of the third side? So remember that you can, if you wanted to make a triangle off of 3 sides, well, you have to, you know that the sum of the first 2 sides has to be greater than the sum of the third side, which means that the third side has to be smaller than the sum of the 2 sides, the other 2 sides, but it has to be greater than the difference of the 2 sides as well. So it has to be between the difference of the 2 sides and the sum of the 2 sides. And in this case, we have 9 is less than X is less than 35. And this is called the triangle inequality theorem. So this part right here is the triangle inequality theorem. It has to be less than the sum. Okay, so 9, so X is between 9 inches and 35 inches. And if you did that, you're going to make a triangle, in this case, a triangular frame. All right, question 14. It says here XU is negative 4y plus 20. So that's this right here. And XW is 6y plus 10. Find the radius of the inscribed circle of triangle RST. So the, basically what it's saying is that this right here is an incenter. And remember, an incenter is the point of concurrency. That's where the lines meet, point of concurrency. So it's where the angle bisectors meet. So these are angle bisectors. And we know that for an incenter, the distance from each of the sides is the same. So from the distance here, distance here, distance there from each of the sides of the triangle is the same. And you can draw what we call an inscribed circle here. And so we're trying to figure out the radius of that circle. But clearly these are both radii, right? Negative 4y plus 20 and 6y plus 10. And so they have to be congruent to each other. So we're going to set those congruent to each other. So negative 4y plus 20 is equal to 6y plus 10. We'll go ahead and combine the y's on the right side, so we'll move that over to cancel this out. And we're going to move the 10 over here to this side. And now we got the variables on one side. We can go ahead and divide by 10, and 10 divided by 10 is 1. So we got 1 is equal to 1y. All right, so we got y equals 1. And therefore, if I plug that in here, right, I would get 6 times 1 plus 10, but that's going to be 16, right? So that means that the radius here is 16. All right, an ambulance is parked in a supermarket parking lot located at the junction of two streets. So we're looking at a junction. So basically you have a street here. We'll call that street 1. And we'll call that street 2. So this is the junction that they're referring to. Okay, and he wants to be equidistant. Equidistant means the same distance from both streets. So he wants to be equidistant from both streets. Where should he be? On the perpendicular bisector, altitude, median, or angle bisector? Well, if he wants to be the same distance from both streets, he has to be located on an angle bisector. So he has to be located in a line that cuts this angle in half. And therefore, by the angle bisector theorem, the distance from both streets is going to be the same. Okay? So that is the angle bisector theorem. And so if you understand that idea, then you know that he has to be located on the angle bisector for him to be the same distance from both streets. So this answer here is the angle bisector. All right, question 16. Find the perimeter. So perimeter is when you add up all the sides. So we're going to add up all the sides here, but we don't know what this side is here. However, we technically do, because we know that because this right here, BD, is a perpendicular bisector. We know that because this is a right angle here and here, and these are the same, 10 and 10. And therefore, if we're on a perpendicular bisector, the distance from the point on the bisector to each of the endpoints here on this line segment is the same. So if that's 36 there, this is 36. And we can figure out the perimeter now. 10 plus 10 plus 36 plus 36. Add up all the sides here. And we get a total of 92. All right, so now this time we're given the perimeter and we want to figure out AD. So AD is the question mark here. All right, well, we know the perimeter is 44. So the perimeter is when you add up all the sides, right? So, and we're going to call this side X because we don't quite know what that is yet. So if the perimeter is 44, then we have 12. We're adding this side, and this side. The side, if you add up all those sides, you should get 44. So we get 44 equals 32 plus X, and we'll subtract 32. And so X is 12. Okay, so now we know that this is 12. We can replace that with 12. And now we know that these are the same distance, so I can mark them with tick marks there. And because that's the same distance, that means that, that means that BD is a perpendicular bisector. So that means this is a 90-degree angle. And that also means that these distances are the same. And if those distances are the same, well, then if they're 20, then each of them is going to be 10. And so therefore AD has to be 10. Okay, so hopefully you follow that train of thought, that logic. You can't just simply cut it in half unless you know that this is the same as that. If they're not the same, then that, messes with the rules here and you won't be able to cut it in half anymore at that point. Okay, so question 18, if BC is 30 and AC is 22, so that's 30. And that's 22. Okay, so then based off of the diagram, that means each of these have to be half because they're the same because of the tick marks here. And these are both halves as well. So these are both going to be 11. So this is 11, that's 11. Okay, not to confuse that with tick marks, of course. So I will say that for 11. All right, so we got those sides, and it says ID is equal to 8. So ID here, this is 8. All right, find the radius of the circumscribed circle. So right here, that's saying that this right here in the middle is the circumcenter, and that means the distance from each of the corners, the vertices, is the same. And so we're trying to figure out that radius. So, and I'll indicate that in red. So we're trying to figure out the radius of any of those. Okay, and then if you were to draw the circle, it would look kind of like that. Not that that's important, but I just wanted to show you that that's the circumscribed circle. I'll go ahead and eliminate it so we don't have so much distracting information. So now we're trying to figure out the radius. We'll call that R. Each of these is going to be the radius. If I find one of them, then I find all of them. So let's zoom in on the triangles that we do know. For this triangle, I'll indicate this one in blue. This one right here, we only know one of the sides, and that's 15. So that's not going to be very useful. For this triangle right here, we also know only one of the sides. That's going to be 11. This one right here, we only know one of the sides. This one right here, we don't know any of the sides. So that's useless right there. We don't know any of the sides here. But then if we go here, we know two of the sides, 8 and 15. So that's clearly the triangle that we want to use. And this is a right triangle because these are both right angles. So we're looking at this right triangle here, 8, 15 with a right angle. And we're trying to figure out this radius. We'll call it R. Okay, so we're gonna, clearly this is the hypotenuse, right? The longest side. So remember, it's a squared plus b squared equals c squared because we're using the Pythagorean theorem here for right triangles. So we have 8 squared plus 15 squared equals, and the hypotenuse here is usually c, but this time I call it r for radius. Doesn't really matter. It's an unknown in any case, okay? So we have, well, we just call it r squared. All right, so now we're going to go ahead and solve this. 8 squared plus 15 squared, that's 64 plus 225 equals r squared. 64 plus 225 is 289. And then we are going to take the square root of both sides. And so that the radius, square root of 289, should be, well, let's double check on that. I'm going to say it's 27, but I'm not entirely sure. It could be 23. So let's do the square root of 289. Oh, it's even smaller, 17. Okay, so the way off there. So my radius is 17. And there you go. And so all of these have to be 17. Question 19. List the angles from smallest to largest in the triangle. All right, so we're simply listing them out. This is a 5.4 problem where you look at you're looking at the theorem 5-9 on the textbook. So here we're going to compare where that angle is related to this side. This angle is related to the opposite side. This one is related to that side. So which side is bigger? Well, or which side is smaller? So 9.2 is the smallest, and so that means angle R is the smallest. So angle R, and then the next smallest is 11.8. So that means that's related to angle P. That's the next largest, and then the largest is 12.3, so that's going to be angle Q. And there you go. That's my from smallest to largest. All right, so question 20. Okay, so question 20, list the sides from smallest to largest. Okay, it's kind of like similar to what we did. This is the opposite of what we did. So this is like the converse of that theorem. So now we're going to look at the angles. So this one is clearly the largest. This one is the second largest. And this one is the smallest. So we're going to look to the opposite side, that one. Opposite side of that one is the blue one. Opposite side of the purple one is AB. So then we can go ahead and list those out. The easiest, the smallest is the purple one, which is the side AB. And the next one is the 66-degree angle, which is AC, followed by the CB or BC. And so that's the order from smallest to largest. All right, guys, that's going to do it for the video. I hope you found this useful. And as usual, I'll see you in the next one.